Hello everybody. Welcome to this video on motion graphs. The objective of this video is to be able to interpret displacement, velocity, and acceleration graphs and know how to use the slope and area of a graph to find the speed and displacement from the motion graph. So let me get my pen going here. So to begin with, we're going to work with a constant velocity graph. So here's a data table for a car going a constant speed. We'll call it a speed here because it's a typical car going down the road here. And every hour that goes by, they stay at 50 miles per hour. So this should be a fairly easy graph to make. So if I want to do a distance versus time, this is going to be my y-axis, and this is going to be my x-axis. And when I graph that, okay, so after 1 hour, my distance is 50 meters. So right about there. After 2 hours, my distance is going to be 100 miles. And then after 3 hours, it's going to be 150. So right about somewhere in the middle there. And after 4 hours, it's going to be 200. Actually, the 50 mark should be right about there. Okay, so that's a nice linear graph. You're going to have something like that. Try to use your ruler and do a straight line right to that. Okay, so there's a distance versus time graph for constant velocity. Couple key things here. The slope of this line, this is the whole part of this video. This is the essential stuff you really need to get. So the slope of that line, well, slope is rise over run. So distance over time is velocity. So here's one of the golden rules. The slope of a distance graph is going to be your speed or average velocity. Okay, so if you were to do a rise over a run there, okay, you get a 50 mile per hour slope. Okay, the next graph here, we're going to take that same data table. You may want to flip back there and graph the velocity versus time, and it stays at a constant 50 miles per hour. So 1 hour goes by, he's still going 50. 2 hours, it's still a 50. This is an easy graph to draw. And it's just going to be a horizontal line. Constant velocity, sometimes I just call that cruise control. Okay, what's the important thing to gain from this? What do you think the slope of this is going to be? Okay, well, slope is rise over run. If I've got miles per hour, and I put that over my run, which would be hour, you simplify that and you get miles per hour squared. That's an acceleration. So the slope of a velocity graph equals the acceleration. Well, what's the slope of a horizontal line? In this case, it's 0. This car is not speeding up or slowing down. It's going to constant velocity. So that's one of those golden rules. The slope of a velocity graph is an acceleration. The next thing we're going to look at is the area underneath the graph. Sometimes they say the area underneath the curve, even though this isn't a curve. So if you were to shade in that area, what does the area represent? Okay, well, you remember from geometry, area is length times width. So our length here is our hours multiplied by our width, which is miles per hour. Boom, the arrows cancel out. You end up with miles. So the area equals the distance covered. Or you could say the displacement. That's the other golden rule here. The area of a velocity graph is your displacement or your distance covered. Okay? Finally, what's the acceleration of this car going to look like? Well, acceleration is how much are you speeding up or slowing down. The acceleration for this thing is 0. It has 0 acceleration. Okay? And if we were to look at the area underneath that, we won't do that on this one here. So anyway, we'll do that on the next one. Okay, now let's look at an object that's constantly accelerating. This would be something like a car that's getting faster and faster, similar to if you drop a rock. Remember we did those other graphs for a falling object? Every second that goes by, it's increasing by 6, increasing by 6, increasing by 6. That's constant acceleration. The velocity is getting faster. but the acceleration is constant, okay? So what's the displacement going to look like for this graph? Look at how the numbers are going up. 0, 3, 12, 27, 40. Those are exponential. It all comes back to this formula here. Remember this formula? VIT plus 1/2 AT squared. That's a parabolic graph there. Exponential because of that. So anyway, we're going to graph the time and the displacement. So we're at 0, 0. Where are we at 1 second? We're going to be at 3. Try to estimate that right about there. And at 2 seconds, we're at 12. This thing jumps up pretty fast. And at 3 seconds, we're going to be at 27. And at 4 seconds, we're going to be at 48. Can't draw a very good parabolic graph. Hopefully yours looks better than that. Okay, same rule applies, but hey, what do we got going on here? How do you take the slope of a curve? Well, you can't do that with algebra. You can do it with limits, but with calculus, you could actually get the slope. If I were to pick a point, say at 3 seconds, and I want to know exactly how fast is he going, I would have to estimate the slope of that line. Okay, I'll show you some tricks when we're in class how to do some calculus here for extra credit. But basically, the slope of that line is going to be the instantaneous velocity. So it's the same rule here. The slope equals velocity. You could do the slope from here to here, and that would give you the average velocity. You have 2 points, and you can get an average slope there, and that's your average velocity. But to do the instantaneous velocity, you got to take the limit or the derivative of that function. We'll show you how to do that later. For now, it's still the same rule applies though. Okay. What if we were to graph velocity versus time for that same object there? So the velocity starts at 0. Okay, after 1 second, you're going 6. After 2 seconds, you're going 12. Nice linear graph here. At 3 seconds, you're going 18. And finally, what's the last one? 4 seconds, you're going 24. Okay, connect that up, and you got a nice linear graph here. And bingo, same rule applies. What's the slope of this line going to be? Here's the deal. You don't have to memorize it. Let the units give you the answer. Rise over run. So I got meters per second as my rise, and my run is seconds. When you simplify that, it's meters per second squared. That's an acceleration. The slope of that line should be the acceleration, and you see it's increasing by 6. You can do a quick and dirty check here. 24 divided by 4, that's going to be 6 meters per second squared, and there's your acceleration. Okay, what's the other deal? What is this area underneath the graph? Okay, remember area is length times width. So our length is seconds. Our width is meters per second. You multiply those together, seconds are gone, you get meters. That's going to be the distance covered. So you could do just the area from 1 to 2 seconds, and that area would be the amount of distance it covers after 2 seconds, which should be 12 meters. You could also do a 1/2 base times height, be the same thing. Okay. Finally, the acceleration for this thing. This is the graph that confuses students a lot. Every second that goes by, it increases by 666. It's a constant acceleration here. Stays right at 6. All right. Don't confuse acceleration with velocity. Okay. The acceleration is constant. Okay. And if I were to get the area underneath this graph, okay, I could do a length times width. So I could do the same thing. Meters per second squared multiplied by seconds. That crosses out that, and I get meters per second, which is going to be my velocity. So at any time you can get the velocity of the object. Okay. So we're going to end with those golden rules, putting it all together. So the displacement graph. So the golden rule is the slope of a displacement graph is equal to the speed or velocity of the object. Okay? When you have a velocity graph, the slope of that graph equals the acceleration. And the area of that graph is going to be equal to your displacement, your distance covered. And finally, your acceleration graph, the area is going to be equal to the velocity. Okay? These are really important rules. When I say golden rules, those are things that always show up on tests. Here's the deal. You don't have to put in the memorization. Just do a rise over run, and then you can figure out what it's going to get you, or do a length times a width and cross out your units, and you can figure out what it's going to get you. Okay? So watch this until you got it down. Graphs are incredibly important. I like to ask a lot of questions on exams about graphs and interpreting graphs. So we'll do lots of practice of this in class, and I hope that clears some things up. So have a great day.